Here's a typical problem at this point. Find the slope of the line passing through the points -7, 12 and -1, -2. Well, I'm going to define the slope by looking at these points on a graph. And I really want you to start to see why I do it this way. Okay, well, the -7, 12, I'm just going to estimate where that is. -7, 12, it's about here, isn't it? Okay, so -7, 12. And -1, -2, -1, -2 is about there. All right, well, I didn't need graph paper for this. I didn't need to put a lot of scale marks. Just kind of estimate where they are. But the line is falling this way. And there's already a couple of observations. For one thing, you can tell that the slope has to be negative. Now, if you're plugging numbers into a formula, you can't tell what it is supposed to be. And if you make mistakes, you won't know. But here, this slope is negative because why? It's falling. It's dropping. Another observation is that negative number must be, an absolute value, must be larger than 1. So think about it this way. A slope of 1 looks like this. M equals 1. It's a 45-degree angle line. A line with a slope of 2 is a little steeper. M equals 2. Why is that? Because 2 is a 2-to-1 ratio. And so the change in the vertical divided by change in the horizontal is 2-to-1. It's rising faster than it's moving to the right. Whereas here, 1 is a 1-to-1 ratio. It's an equal ratio. And then a slope of 1/2, for example, well, actually that slope's probably more like 1/5. But it's up 1 over 2. So it's moving faster horizontally than it is vertically. That means it's a fairly flat line. So now over here, it's a 45-degree angle line would have in this direction would be -1. A steeper line would be a larger absolute value number than -1. By that I mean it could be -2 or -3, something that is a bigger number in the negative sense than -1. So I expect my slope to be, well, technically less than -1, which means it could be like around -2 or -3. All right. Well, let's go ahead and calculate it. But I want you to see that the slope describes a direction that the line is pointing in. So, and that's interesting, I think. All right. Well, let's look at what happens here. Well, I move from this point down to this point, and it's a negative slope. So I'm going to fall by how much? How much do I fall? Well, I'm falling from +12 down to -2. So that's 14 units. I'm dropping by 14. So I'm going to call this -14. And when I go left to right, I'm going from -7 over to -1. So -7 to -1. Okay. It is how much? That's 6 units. Count over, that's 6 units. Let me get my right color here. So the slope for this line, again, it's a ratio of vertical change to horizontal change. By ratio, I mean it's a fraction, it's a division. So it's -14 divided by 6. And always reduce your fractions. We can simplify this fraction, -7/3. So the slope is -7/3, which is -2 1/3. I predicted around 2, and it's, well, a little bit more than that, I guess. Well, that's an example of calculating the slope. We'll do more as we go work our way through these videos, and also in my book you'll see there's a lot of this. This is how I like to show it. How you do it, if you're my student, I don't care. You do it your way. If you want to take your chances with a formula and be my guest, let me tell you that people who use the formula make more mistakes than people who learn what slope is and plot it out like I do. Not saying that people don't make mistakes this way, they do, but not as many. So it's up to you. All right, I want to show you one little brief application, real simple brief application of slope. It's going to look like a word problem, but it sort of brings together, to me, for me at least, what slope means in some more of a real world sense. So I'll erase the board and I'll put that up there.